Hey, good morning, guys. Just wanted to throw out a quick video here, just going over the quiz worksheet that we had assigned. Um, it seemed like a lot of you did pretty well with this, which I was happy to see. Just let's take notice of a couple things. So, when you set up your HO and your HA, your hypotheses for chi-squared goodness of fit tests, for our purposes, like I said, you can abbreviate that HA. It's just pretty much the HO is going to be in this case did not change or is correct and not correct. Like that's basically it in context of the problem now. So in this case, we want to try to figure out if these boxes of cereal, the distribution of the sizes changed once the price difference took place. Okay. So our HO, the distribution of sizes of all boxes sold of this brand of cereal, did not change when the prices did. The HA would just be the distribution of sizes of all boxes sold of this brand of cereal did change. Okay. For us to find our expected counts, well, we got to look into the problem here and see the percentage breakdown that they gave us. So we were told 10% of the small, 15 medium, 60%, and then 18%, or no, it was 15% of the jumbo. Okay, so our expected counts were 12, 18, 72, and 18. And I listed them again here in this box. All right. The conditions. Random. We were told that the data came from a random, simple random sample of statements or sales records. We would have to assume the 10% condition is satisfied here. And then the large counts condition, it would have to be all expected counts need to be at least 5, all right, as is the case with this particular example. Now, in the next problem, I brought up the calculator again just so I can kind of walk you through how we want to do this. But it's also important that you understand the work behind it. Okay, so the chi-squared equation is the observed minus the expected squared divided by the expected. And it would be the sum of each one of the categories. All right. If I was to use my Inspire, I'm going to open up a list and spreadsheet. I don't think I need to even label the columns here since we're not graphing, but I'm going to put our observed counts in column 1 or column A. And I'll put the respective expected counts in column B. All right. From there, we can run the test. So statistics, stat tests. Remember, there's 2 of them. Right now, goodness of fit. Our observed list is in column A. The expected should be in column B. And we want our results to go in C. Now, as far as degrees of freedom, well, we have 4 different categories, right? So 4 categories minus 1 leads to a degrees of freedom of 3. All right. And if you notice here, here's my chi-squared test statistic, which we got over here. Okay. And the calculator also was able to give me a p-value when I run the test. If you notice, I put down something else over here, chi-squared CDF. So I just want to also take a minute and show you how to go about it that way. Just like in other chapters where we would run the test, we'd get the p-value, or we would use like TCDF or norm CDF. Let's just take a quick look here on the scratch pad. So menu, probability, all the distributions, right, that we use are all right here. So norm CDF, TCDF, inverse T. Here's where chi-squared CDF would be. Okay. Our lower bound, because these are always right-tailed, our lower bound will be our chi-squared statistic, so 9.514. And the upper bound will always be a big number. Remember, these curves are different than our normal curves. All right? These are not bell-shaped. They are right-skewed. They peak and then they tail off. Again, degrees of freedom is 3. And there's our p-value. Okay. We would conclude, it's a little cut off here. We would conclude just like we would in previous chapters. This p-value is less than our significance level. We reject the HO, which means that we have evidence that the distribution of boxes sold changed when the prices changed. All right, the prices made a difference. It says, based on our answer, which error is possible? Well, because we came up with the rejecting of the HO, that could possibly lead to a type 1 error, which would mean we concluded that we had evidence that the price change did affect the distribution when really, it did not. Okay, so type 1 error, reject the HO, but the HO is actually true. All right, and then finally here, like I mentioned yesterday, you're going to see a question where it says, use the components of the chi-squared test statistics. So if you did it like this, you could see, which one of these attributed to this the most. And that would be the 4.5, obviously. Okay. If you let the calculator get that chi-squared statistic for you, let me just go back to right here where it says component list. If you scroll over it, you can see the numbers that correspond to the order in which you kind of entered the information into the calculator. So 4.5 would be the biggest contributor to our chi-squared statistics. So as you can see what I wrote, the observed count of the jumbo size boxes was much larger than the expected, all right? Which would mean this made the biggest impact, okay? So guys, well, I'll also post this answer key. That pretty much wraps up the first section of Chapter 11. Hopefully we have a good understanding about it. Please ask me any questions, shoot me an email if you have any. In addition to kind of going over this video today, I'm going to put some book problems. If you don't have a copy of the book with you, just let me know or ask somebody in class. I'm going to assign 2 problems that are like the full chi-square test, kind of that you just had to run here. And then I'll assign the multiple choice. That's it. But you can always, do some practice problems out of the book or read through your notes. Just let me know if you have questions. All right. Thanks, guys. Talk to you soon.